In this video we're going to keep solving trig functions, and if you watched the previous one I would have said that we're splitting it into two videos. However, solving these trig functions can take quite a few steps and be quite time consuming. The other thing is, I had a look forward at these questions just briefly, and I noticed a little power of 2 over here, especially when we've got something where there's a sine squared and then a sine on its own, and I'm starting to think, maybe we have to turn one of these into a quadratic at some point. So let's get into it. The first one is, whereas sine of 2x equal to cos of 2x. Now, as we would have just learnt from before, there's a little 2 inside here, and I need to check, is that the same as what's in my domain? If it's not, we'll just quickly manipulate our domain to make life a bit easier. So we're going to go up to 4 pi, so 2 revolutions. So I'm going to draw my circle. Now I'm going to think. All this question's really asking me is, where is sine equal to cos? Now, you would be tempted to immediately think, well, at every single 45 degree, up here, down here, yeah. However, not only are they equal in magnitude, but they're equal in direction. So what I mean by that are, they're equal in terms of positives and negatives. So that's going to rule out these two quadrants, because cos and sine are the same value and same sign. They're both positives each up here. Then down here, they're both negatives. So we're at pi on 4, and we are at 5 pi on 4. Now that's if we are doing one revolution. We also have a second revolution, where it would be all the way up here and all the way down here. So all we have to do is just add a full revolution to that. So if I took pi on 4 and I added 8 pi on 4 to it, we would get 9 pi on 4. Same down here, I take 5 pi on 4 and I add 8 pi on 4, we're going to be at 13 pi on 4. Now, that means 2x equals pi on 4, x is pi on 8, and what you're going to notice with all of these is we're just having to double the denominator. So 5 pi on 4 is going to be 5 pi on 8, and the same trend is going to continue. So what that means is we're going to be at 9 pi on 8, and then we're going to be at 13 pi on 8. So this question was essentially tricky in terms of knowing what quadrant you're in, whether sine and cos are positive or negative, and then obviously knowing how to solve it. So B, 2 sine squared theta plus 3 sine of theta, take 2 equals 0. Now, this is essentially saying that we are between 0 and 2 pi, which is good. The way the question is written though, this has a theta in our bracket, and this has an x in here in the domain. I'm assuming that that should have just been a theta. There's no transformations on my angle, which is awesome, so I don't need to change up my domain. Now looking at this, this is looking like a quadratic straight away. I've got a power of 2, power of 1, and then there's actually nothing on the 2, which is screaming something like an ax squared plus bx plus c. Okay, so we're going to try it out and see if we can multiply to give, add to give, and see what we can do. So if I said, hey, let a be sine squared theta, or sorry, let a be sine theta, then this whole equation then becomes 2a squared, because sine theta is squared, sine squared theta, plus 3a, take 2 equals 0. So now we're going to use our normal multiply to give. What two numbers multiply here to give -4 and add to give 3? So multiply to give -4, add to give 3. I'm going to go with a positive 4 and a negative 1. Now, we can't forget, I've got a 2 at the front here, which means I need to put that 2 here, under here, under here. So that's going to give me a plus 2, a take a half. Now, this is where the quadratic equals 0, so we should be able to bring out some null factor law. A plus 2 equals 0, so a is negative 2. And then a take a half equals 0, so a is a positive a half. Now, we said before, we're letting a be sine theta, which is this. So what we're going to do is we're going to swap it back out now. So what we're going to say is sine theta is negative 2, and sine theta equals a half. Now, all of this we need to think back to, and I'm going to bring my blue highlighter all the way up to this domain, where on a normal unit circle, this is why we draw them in every single question, where on a normal unit circle do you see sine equal to these values? So where is sine of an angle equal to negative 2? Nowhere. So, not possible. There is nowhere on a unit circle where sine is equal to negative 2. The biggest value you're ever going to get out of sine is up here at pi on 2. It's going to be positive 1. Even down here it's negative 1. Okay, without transforming this, that's never going to happen. So, next question. Where is sine theta equal to a positive a half on a unit circle? Well, positive a half, that's going to be in the top quadrant. So we're going to be at pi on 6. And then, oh geez, that line was something. And then we're going to be at 5 pi on 6. So what that means is I have two angles, and we would write that as theta equals pi on 6 and theta equals 5 pi on 6. Two solutions for this question. So C now. I'm going to move C up here just so we've got enough room. We've got cos squared of 2, I'm going to call it A. I know it's alpha, but I'm going to just call it A, so bear with me. Equals 0, and we're going from negative pi A up to positive pi. Now again, don't get tricked. We've got a 2 transformation, so we need to transform our domain here. We're going to multiply it all by 2, so we're going to go from negative 2 pi to 2a to positive 2 pi. So cos squared 2a equals positive 1. I'm going to move the 1 over, so that means cos of 2a equals the square root of 1. Now we've got a full revolution in reverse in the negative direction, and we have a full revolution in the positive direction. And the tricky bit about this is right here I wrote the square root of 1. What we need to not forget is there should be positives and negatives. Cos can be positives and negative. So on my unit circle, let's go in the forward direction in blue. Where is cos equal to either 1 or negative 1? Well, at 0. Then we're at negative 1 at pi. And then all the way back around here at 2 pi. Then in the yellow direction, also 0. Then negative pi. Then negative 2 pi. So there's 5 different solutions. I know we want to say 6, but let's be honest, 0 and 0 are the same answer. So there's 5 different solutions. So for each of these, we're going to go through them one by one. 2a equals 0, so a is 0. 2a equals pi, so a is pi on 2. And 2a equals 2 pi, so a is pi. Then, in the negative angles, We already saw before that 2a is 0, so we can just ignore that. We already know that. That was a solution. We know that 2a is negative pi, so a is negative pi on 2. And 2a is negative 2 pi, so a is negative pi. And those are our 5 solutions for a. Now, with questions like this is pretty much where you need to be up to and what you should be pretty confident with doing questions like this before you head into your exam. It's a big mixture of skills, such as you need to be able to know exactly which quadrants sine and cos are positive and negative in. You also, if we're looking at question B, need to know how to turn a trig function into a quadratic, and you also need to know what solutions are just not possible. And then for part C, you need to once again be able to manipulate a domain, not lose track that square roots have a positive and negative solution, and of course, like we saw, you need to know exactly what values of sine and cos are on these horizontal and vertical axes. All right.